Hi, this is Bennett.
Hey, Bernard, how are you?
Hi, I'm fine. Hope you're doing well.
Doing all right. Did you have a good weekend?
Hello, everyone.
Hi, Daniel.
Bonjour.
Good morning, good evening, good afternoon, whatever it is, wherever you are.
Close to freezing lunch.
Ah, yes. How was everybody's weekend?
Well, for me in Montreal, freezing. So technically,
My son's in New York, and he just sent a picture of outside his dorm room, and there's just a little dusting of snow out there, but Montreal is probably
no, we have no snow, but it's like minus 19 over the weekend. So
oh wow, yeah.
yeah, and Celsius, not Fahrenheit.
Yeah. Well, let me check. Do we have either of our fearless leaders here? Let's see. Don't see anybody yet.
So Sana said she would not attend today.
So, okay, well, is Verizon here? I see a message from Sana saying Verizon plan to present today. No, even if you don't have Sana or Kashik, I imagine Verizon can still present and we can review the recording later if they'd like.
Hey John, I'm Bharat from Verizon. I'm planning to present on the best practices from our side.
Okay, well, why don't we just get started then? I'll just say, yeah, thank you everybody for coming. Today is December 12th, 2022. This is the NAFIO SIG Network Architecture meeting. And I don't, Tal, is there an agenda somewhere or are we just, I know that the intent is for Verizon to present, so maybe we just go ahead with that and then do Q&A unless there's an additional agenda items that you're aware of.
So I'm looking at the agenda document, and it actually has not been updated for a long while. But I think there's a new system. It doesn't use the Google Doc anymore.
I think they use
Sorry,
a
I'm not on
spreadsheet.
top of things.
Yeah, no, it's just not our SIG, so we don't have the same.
Yeah.
I think they were using a spreadsheet. I don't know if anybody on the call has a link to that, or if it's in the original agenda document. Otherwise, why don't we just get started?
Sure. Let me share my screen. Let me go. Let me know if you can see my screen and this Google slide.
Yes, we're good.
Looks good.
All right.
You could go into presentation mode. That would be nice.
Okay. How about now?
Yes, great. Thank you.
Okay. So, so in this call, the main agenda of this presentation is to give a brief introduction on the Verizon web scale environment, which is like a flavor of Kubernetes platform, and to discuss about the use case of initial challenges we had with running operators in our clusters, and then says what are the best practices if you want to, to put them in the NFVO compliant operators. I understand we still not sure about the scope of what are the deliverables on the NFVO, but if you want to deliver any operators, or if you want to release the CRDs, and when other companies to develop the operators based on those CRDs, we want to enforce some of the best practices of operators to those CRDs and other companies operators, right? So we want to suggest few best practices so that all the NFVO compliant operators work well in all the environments across the industry, right? So to just start with the Verizon's web scale environment, it is one of the flavor of Kubernetes platform we are running, and it is a multi-tenant environment, which means not all the applications have the admin privileges in the cluster. So you have multiple applications running in the cluster, and when you onboard a new namespace, we do all the role bindings to those application teams so that they will have access, or tenant admin level access to those namespaces, so they can deploy all the pods, application, all the Kubernetes objects in those namespaces. So it's like each application may have one or more namespace, and through automation, we do all the role binding to those application team in those namespaces. So, and these tenants will not have access, as I said, they will not have access to cluster level resources. So any CRDs or any cluster level objects, they have, few of them will have a read-only access, and that's they cannot even see the cluster level resources. So, and once we deploy the namespaces, every namespace in our environment has a resource quota associated with it. So there's no namespace in our application running in our cluster without a resource quota. Every namespace is like dimension with a CPU, memory, and few other resource requests. So all the applications that are deployed in those namespaces have to define what are the CPU and memory requests and limits. And web scale is like any other enterprise cluster infrastructure. It's an air-gapped environment. There's no internet access to any of the pods in this cluster. So we have our own registry, Artifactory, where all this Kubernetes platform infra pods will pull those images from the registry, and even application. They pull all those images from the local register, private registry, but not from the internet. So there's like a bird's eye view of a web scale environment. So far we have.
Can I? I'm wondering. Do you mind if we jump in and ask some questions?
Sure. Please interrupt whenever you want.
Yeah, no, this is great. This is awesome. First, will you be able to share these slides afterwards? Put them on the drive or something?
Sure, I will do that.
Okay. But then the other thing is, so a couple questions. One is, okay, so you have the concept of a tenant, and that tenant has access to, and that it sounds like your tenancy is tied to a network function. So you say this network function is a tenant, or is a tenant a different concept than a network function?
Yes. So when I say tenant, it's like one of the application that
Okay.
wants to deploy in the cluster. That's what.
Okay, and then they may have multiple namespaces associated with one of those tenants. How do you, now Kubernetes itself doesn't have this concept. So how do you manage that? So then like you have, say there's 3 or 4 or 5 namespaces associated with one tenant. Do you do it through naming, through labels? Is it enforced via some CRD and operator? What's your strategy?
Anishka. Bye, Anishka. Anishka. Then
So someone is not on mute. So this tenant, when I say tenant, there is not any logical entity. So if I
Okay.
want to deploy some network function, some application, let's say, so I will. So this whole team who wants to deploy the application, we are calling as tenant. And if their application has to deploy in 2 or 3 namespaces, let's say,
Okay.
so we will do the role banding for the group or the user in all those namespaces. So they will
Okay.
have all the permissions. Let's say they have deployed 3 namespaces. These users who owns this application will have a tenant admin level privileges. So I mean, they can create, delete, update all the Kubernetes
In the
resources in
namespace.
those 3 namespaces.
Right.
Yeah.
Does that include the quotas, or the quotas are separate?
Quotas, no, they cannot modify the quotas. It's a platform admin who can create the quota once the namespace is created.
So you have a set of, how do you capture that? Is that in a CMDB, in a GitOps repo? Like what those associations of tenant? Is it like somewhere? If next week, what I mean, I have so many questions that I maybe I should let you continue. But like, for example, if you've got, is this on, how many clusters is this on? It's an air-gapped environment. Are these edge clusters, or are these these regional clusters, or it applies to both?
So
Like,
yeah, so these clusters, instead of, I mean, these are, whatever I'm telling is more applies to a lot of the clusters in general in web scale.
okay.
I'm not talking in specific to any type of clusters in the web scale. So any other question, John, or did I
Yeah,
miss?
I'm sort of wondering how you manage, is each cluster managed individually? So, or do you say need to do this same, somebody says, I want to deploy this application, and they want to deploy it across many clusters. That means that same tenant configuration and namespace creation needs to be done across many clusters. Are you managing that manually, or is it part of some CI pipeline? Or you don't have to, you might not know all the answers to this right now, and that's fine. These are the kind of questions that pop into my head, and I'm trying to think about how that relates back to Nephew. So that's all.
Okay. So, I mean, we deal with each application in one cluster at a time, right? There's a lot of process goes on there behind the scenes. And then once they decide, okay, they have to deploy this application in this cluster, and then there's some automation that gets triggered to create all these namespaces, resource quotas, based on application requirements, and then they deploy that application in the cluster, specific cluster. It's not like all concurrent application deployment across multiple clusters at a time.
Okay, cool. Thank you. That's really helpful.
Yep.
So,
All right.
hi, Bharat, a quick question if you don't mind. So
Yeah, sure.
off late, we got many new initiatives in the Kubernetes community for multi-tenancy, right? We got hierarchical namespace controllers, virtual clusters, CAPI nested, and so on. So have you guys looked at it? Is there any interest in moving towards it?
To be frank, I have read that Kubernetes proposal on hierarchical namespaces, but I'm not sure it is the version we have running that has the hierarchical namespaces implemented. That version is already there in our cluster. I'm not sure, but I have to think about that. But I don't have correct answers for you as of now.
No problem. That's fine. Thank you.
Yeah.
Okay.
Yeah.
Just curious. So.
Okay, no problem. So coming to the types of operators that we are running in the web scale, we have generally categorized these operators into 3 types. One is where we have dedicated CNF operators. If we have any network function, they want to deploy everything through the like all the lifecycle management, operation, update, rollback, everything through an operator. So those are the categorizing as a dedicated CNF operator as a type 1, where all the 5G code function can handle their LCM by the operator itself. The second type is this shared CNF operators, where these operators belong to the similar network function from the same supplier or from different, but it's like more of similar network function, where they want to do the backup, restore, or config update, all those operations which are common among few operators. They share across multiple applications, right? So those are the type 2 operators, and the type 3 is a utility operator. This comes not from the application stream, but from the platform itself. Platform itself, like the DB, like multiple DBs that we want, the application wants to use, the cache related layers, all those that any application wants to use. Those are the utility operators we categorize. Those are coming from the platform itself. So if any application wants to use some MongoDB or some MySQL and platform admins will provide those CRs to the application team, and the application team will just use those as CRs, and they won't bring their own operator as such, right? So those are the three level of three categories of operators that we are seeing that running in the web scale so far. So coming to the operational challenges, so we have categorized 4 types of challenges initial in running the operators in our clusters. I mean, just to call it out, these operational challenges, it's not like they are impossible to solve. There are multiple tools to solve all these challenges, but there is no standard way of, there's no single way of solving it there. If you have to use some tool to solve one problem, then you have to use a different tool to solve a different problem, right? But what we were looking as a committee, as part of NFIO, if a NFIO compliant operator come, we want to deploy those operators, then if you should have some opinionated way of operationalizing all these operators, so that all the best practices would be there, and we know that all the operators coming from NFIO will have this process, which will work for every across all the industries, right? So the first operational challenge is on the RBAC. So as you see in the previous slide, we have different types of operators, right? So if the platform admins has to create for type 1 operator, right? They have to create a role and which will give access to those operators CRs. So for example, I'm app A and I bring a type 1 operator. The platform, I can install in a different ways that I will show you in the next slide. I can install in different ways. Once I install, because the CRDs or CRs are cluster level resources, so as an app user, I will not have access to it, right? So the platform admin has to create a role and do a role binding to all the users in that app team, and then give access to those. And same thing for type 2 and type 3. So for type 2 and type 3, the platform admin, instead of creating a role, they can create a cluster role and give access to all those API CRs, and then do a binding to the application team. So the next week, if the app B comes and I want a MongoDB CR, let's say, then the platform admin has to create the CR role binding for those new app team B, right? So RBAC is either we have to do some automation, or we need to have a tool which will do all this role and role binding generation if we give the users and group names. So it should automatically generate it. But as of now, if we use a normal operator way of deploying, like I get a operator from Helm chart or somewhere and then deploy it, then the platform admins has to do all the work to give access to the users who wants to use these operators, right? So RBAC is one of the initial challenge that we had when we are dealing with these operators. And second one is packaging and distribution, right? So we have different network function, different applications running in the web scale environment. Some operators are bringing their some application team bringing their operators through Helm. So they will put operator pods in the Helm and then as the platform admins, because they cannot put CRDs as part of the Helm chart because they don't have access to it. So they have to request the platform admins to create the CRDs first and then deploy the Helm chart, because the Helm chart will have operator parts. Now it will listen and watch on those the CR events, CRD events, right? So the RBAC and back and forth between the different teams is a challenge with bringing an operator in the Helm chart way. The other way is, I mean, there are multiple ways. This is not exhaustive list. The other way, people bring the operators through OLM bundles. If the operators are in operator marketplace or operator hub, we can get those and pull it into our registry and make it available for users. But the type 1 operators, because those cannot be distributed on a public operator marketplace, right? They have to give it to the specific telco operator, and then they will extract it or repackage it and move it to their own catalog and then make it available in their own local marketplace or private marketplace. So if someone have to bring this operator through OLM format, then the platform team has to do some heavy lifting to make it available in their own private registries, so that app can install those operators. So there are different pros and cons of packaging different operators. We have to see which can be a better approach for our compliant operators. Right? And the second problem with the packaging and distribution is configuration parameters, right? So I don't know if anyone noticed, some of the operators, they have the hard-coded image paths. They're pointing to docker.io, Nginx, and then if you run that operator directly in a air-gapped environment, you cannot deploy it because it cannot reach this internet-facing registries, right? So you cannot also modify those image paths unless you just extract all the operator and then change it and then bundle it again, right? So if there is a way to, I mean, there are multiple ways, but we have to make sure that all the image paths are configurable so that when someone is installing the operator, they can modify the image path, at least the base path, and then install the operator. So that works for all the air-gapped environments, right? Second one is, this is related to the quota. So if anyone using resource quota in your namespace, and let's say MySQL, if you use a MySQL operator as an example, and you have installed the MySQL operator as a platform admin, and you gave access to the application team to use those MySQL operator and to deploy that MySQL cluster for your application, right? So he can create a CR, but if there is no option to provide a resource quota details in that CR, this MySQL operator will just install the MySQL pods in one of the namespace, but Kubernetes will reject all those pods because the resource quota is installed in the namespace, and if your pods that doesn't have a resource quota, Kubernetes outrightly reject all the pods. And if there is no way to pass those resource quota through CRs, then there's no way to deploy those pods in the namespace unless I have to remove those resource quota from the namespace and then add it back later. One of the workaround, right? So there should be a flexible way to pass all those parameters like resource quota, node selectors, or affinity rules, whatever the needed for any environment. Those should be able to configurable while we are installing the operator or while we are creating the CRs.
So I can jump in here. Yeah, so this is, I almost feel like you're like I paid you or something to say all these things, right? These are all the kinds of problems that we're trying to solve with the second pillar of Nefio, which is the configuration as data piece, right? A lot of this, things like being able to change the registry URL easily without sort of breaking the Helm chart, if it's, we don't use Helm charts, or and that's part of the reason why is that you have to break them in order to do a lot of these things. And you have to break the chain back to that distribution channel, the sort of relationship between the original package and your package if you start forking things. On this last point, so I totally, this is great to see, you know, not great that you're facing the challenges, but these are squarely within the challenges that we hope to solve with Nephew. And some of them would be through technology, and some of them would be through, like you're saying, convention or opinionated ways of doing it. One of the challenges in this very last one, if I understand it, is you're talking about if you're using operators at runtime to create the manifest. So in the discussions we've been having, I've talked about sort of two strategies. One is a traditional operator strategy, which is you provide a CR and the operator creates the Kubernetes manifests. And that while that's quite useful in certain ways, it has exactly the problems you're talking about. If the author of that operator didn't think of the thing, then it's not available in the CR, and you're in trouble. The workaround, just to be clear, you could work around this issue, likely through mutating webhooks, but
Exactly.
there's risks with you mutating webhooks, right? They're not. Anyway, there's risks with them, and there's complexity with them.
Right, but also the mutating webhook, right? I mean, for each such problem in those operators, you have to write a mutating webhook for each of those problems, right? It's not one single solution for all the things. Yeah.
So the problem is, like, so I've pushed in this community and in our other SIG calls pretty forcefully for this shift left idea of operators that just render resources aren't useful. Now we're not gonna, I push really hard for that, not because I believe there's only one way to do it and that we should just shift everything left, but because of the momentum or the weight sitting, the inertia on the existing operator side. Everybody does it this way because we've been doing it this way for 4 or 5 years. So I think that part of this will come out of trying to evolve a culture around the Nephew operators that puts the necessary things at the runtime operator and everything else shifted left. But we're not going to change all those MySQL operators and all those things that are out there already. So yeah, we'll need a strategy around both. But I really appreciate you raising these challenges so clearly. So I guess that's my main point.
Yep. Thanks for acknowledging, John. So definitely the operators that are already there in the the operator marketplace or operator hub, wherever they are, we cannot change all those operators, but at least the ones that we are creating from the Nephew community, I think those are the first thing we have to aim, maybe, right? Any other questions so far?
If I may, one question. So we are talking specifically in the web scale environment, right?
Mm-hmm.
Is there a way for a network function to specify required operators?
Can you elaborate on that, Tal?
So if you have a network function that needs a bunch of operators to work, does it have to package those operators themselves, or is there a way to specify that during deployment it would need certain operators and in addition to other requirements it might have from the infrastructure?
Right. So there's no standard way to tell that. So when we are onboarding some application, the application team will give you a requirement of these are the operators that we want to be deployed to support this application. So they gave those lists, but there's no standard way of telling, like in the packaging itself, these are the operators that's part of this application. There's no standard thing. It's like it's mostly a human way of communicating so far, but yeah.
I mean, this is the huge challenge, right? That we assume that the infrastructure will be there, and it's a different role within companies, right? There's this is the chicken and egg problem that we keep facing, I think, with network functions, that the requirements, it's not just having operators, that you might need requirements from the cluster itself, right? Certain kinds of nodes and other things with certain drivers installed, certain CNIs installed. So and actually those have even more complicated packaging requirements, right? If you say that you need a certain CNI, well, that is extremely operating system specific, and It is not. It is a host application. Usually, it's not a Kubernetes. You're not even dealing with the Kubernetes world at all at that point, right? If you need to install a certain fabric, for example.
Yeah.
Yeah.
So it's mostly like how
do
we
you
distribute this Python application and have a requirements.txt, and then whenever I want to install, just run pip install requirements. If there is a way for that for all the applications to run a Kubernetes, that would be easier.
But would you install
so
these
easy.
dependencies automatically, or would you just list these dependencies? I'm not particularly for some of these, CNIs and even operators. I don't necessarily want the dependencies automatically installed, or at least not default automatically installed. I may want to know about them.
Right.
But
I mean, they don't have to be hard requirements, but I believe that there needs to be some sort of standard specification for it, right? At least for validation. How that actually happens, I don't know, right? Because, for example, you might need specific hardware. There are certain things that are physically impossible, right? So when you design a whole application, you design it from the hardware spread, etc. But I keep saying with Nefio, our goal is not to boil the ocean. I don't think we need 100% automation for everything. I mean, we should someday. We're not going to achieve it. But if we can move the dial a little bit more towards automation, we will just save costs and these kinds of integrations and moving forward. So, I mean, we have said that infrastructure is in scope, right? We do intend to allow certain aspects of the infrastructure to be configurable. Of course, infrastructure is a very big word, right? That includes those things that I call adjacent PNFs. It could be a top-of-the-rack switch. It could be a router somewhere in that data center. It could be a lot of things that are, even cooling and power is part of infrastructure, right? So we're going to have to narrow down, I think, into what is possible. But I think exactly presentations like this remind us what the challenges are. And we're going to have to pick which challenges we can actually address and which we can't, right?
Yeah, and I think building out the framework for both the automatic, but also just simply the scheduling, right? Like just if the underlying layer flow can advertise what is available, even if you can't automate mutation or changing of that because it's you got a rack and stack so many years, you don't have to change it. At least you can decide and raise a thing saying, hey, we can't deploy this network function because the underlying infrastructure doesn't support it.
Well, we mentioned that one way to manage operators is using OLM. For those who don't know, that's the operator.
There's somebody with a lot of background noise. I don't know who that is or if they can mute.
So OLM is the operator lifecycle manager, which is part of Red Hat's OpenShift. And that's exactly what it tries to do, manage the lifecycle of operators over a cluster. So that is a very standard way, actually. There are custom resources where you can just give an operator a subscription and you can detail versions and other things. And that is a very standard way to do it. Now, I don't think it actually is designed around the Nefio structure of having management clusters and versus the workload clusters, but or if something as full-blown as that is needed in Nefio. But that, again, is a component that could potentially be part of Nefio. I mean, this is within the realm of possible, right? Something that could be managed. So yeah, I'm thinking, to answer the question, are we expecting operators to be installed automatically? I would say, why not? It's already being done. What we would need exactly for Nefio, we would have to specify those requirements specifically in this SIG, I think.
Yeah. Also, the OLM, though it claims it can support non-OpenShift environments as well, but there's no easy way, or I feel it's more complex on the non-OpenShift environments, if I say so. But we need to get what are best practices from those OLM and other tools, and then put part of the Nefio, I feel, because we may have environments as part of our community which are not OpenShift, so we should be able to
exactly. But those kinds of translations are pretty easy. So there can be a Nefio custom resource defining an operator requirement or even a CNI requirement, something like that. And the expectation that there would be an operator that translates it into some other functional component that does it. So it could translate that into whatever OLM needs. Or, you know, we can supply a reference implementation in FEO that's something just very simple, you know, and just does the job, something like that.
Yep, that makes sense. All right. Any other questions?
Bharat, just to add to your point, right? So Tal, thing is that for type 1 and type 2 operators, right, the installation instructions will be provided in the CNF installation guide, which any vendors give it to Verizon, right? So accordingly, those operators are deployed in a sequence. It is not that someone is deploying it manually per se, but the recipe in which order those operator needs to be installed are coming as part of the CNF installation guide, which basically any supplier gives to a CSP.
Correct. Yeah, that I didn't mean, I wasn't clear, but I did mean for type 2 and type 3. In my
For type 3, it would be the platform team, right? They're gonna work with, again, the supplier, what type of utility operators you require in our ecosystem, and then Verizon would automate it.
You're talking about what Verizon has right now. Yes, I understand. Yeah. I was talking about the ideal that we're looking forward to in FEO.
Yep. Okay, got it.
Right, and by the way, these things aren't new for Kubernetes, right? We've had platform requirements in OpenStack, and there's nothing new there. But we have the opportunity for more automation right now because we can extend the platform itself.
That's true. I agree.
William,
So,
your hand up. If you had something to say, you need to jump in.
Yeah, I just wanted. I didn't want to derail the conversation. I have a bit. I mean, I think it's similar or related, but not exactly. But what I'm feeling from the feed, I was a bit late, so I was. But is it correct that today, when people deliver an operator of some sort, they build it within their own set of environment? And what I'm hearing is that we need to be more flexible to accommodate different personas that consume it, different parameters that needs to be set potentially, and be more independent of the dependencies that they have, and specifying it in a different way, so that you don't have these explicit requirements that have to be accommodated. So, is that do I sense correctly what you have been explaining so far?
Yeah, that's right. So it's basically what are the operator you tested in the environment. So if you distribute to a different environment, to a different Kubernetes cluster where they have some constraints on the cluster itself, like privileges, access to the registries, and all those things. So the CIs that you're developing should have a flexible to configure those parameters, right?
Yeah.
So that it won't work just in a developer environment. It should work in all the different Kubernetes, all the flavors of Kubernetes environment without any issues, right?
Yeah. Plus, also, I think if you look, if I refer back to your type 1, it's a namespace-based operator somehow, right? Whereas the type 2 and 3 are cluster-wide. Is that correct?
Yes. So the first one is mainly focused on a single namespace, whereas type 2 and type 3 can be, I mean, those operators are watching multiple namespace, not just one single namespace. Right.
And so how would one know? So would you like to have the flexibility that if you have an operator, you can by yourself define whether it's namespace based or cluster based? So that's something you would like, probably, I'm assuming.
Yes, I mean, so while installing an operator, you can tell whether you want to have namespace scope or a cluster scope, and then you can tell which namespace you want to watch on. So when you create a CS, if you tell you have to watch only the CR events coming from namespace A, then it will just watch on namespace A. If not, you can tell the whole cluster, so it will watch for CR events from all the namespace in the cluster. So while installing operator.
Yeah. Even today, you compile it in. If you take the controller runtime, you compile it in, right?
Yes.
So you don't have the flexibility if you do that way, is what I'm trying to get to. It's so if you take the goal construct and if you say the controller runtime, you say it's namespace based, it will only be namespace based.
Right.
So so in some cases, so that's why I'm getting to is depending on how you deliver it, you might not have the flexibility to customize it.
So when I say customizing it, right? Let's say if you have deployed an operator, a MySQL operator again, in one namespace to watch events on one namespace, and if it doesn't have a flexibility to tell what image to use, what resource code to use, then I cannot install the MySQL pods in a single
100%.
namespace.
Yeah,
Even if I install that in multiple namespace, the problem still exists. So irrespective of how you install that operator, what namespace to watch, the problem of configuring the runtime parameters and all still exist, right?
Yeah, no, I agree. Yeah. No, what I'm trying to get to is typically people build their operators either namespace based or cluster scope based, and that's the option. And then if you only do namespace based, you're inflexible. So in other words, it's very hard to you cannot customize it almost.
Yeah.
And I think what I'm hearing here is that you would like to have more flexibility on customizations based on the environment and you want to deploy this in, so that you can tweak it based on your environment itself, which is possible, by the way, which is possible.
Which is possible if the developer has designed the operator in such a way where it can extend the CRs.
Correct.
Right? Yeah. And then the controller can listen to those extend, or you have some object key value in the CRDs where it can accept any key values. So in that case, if controller is written such that it can accept those key values and determine what to do with those new key values, then it would be flexible. But if it cannot accept the resource code or a new image path, the controller image is like completely, it cannot do what. Right, so we need some flexibility and configuration there. That's the main.
Agree. Yeah. Thanks.
Yep. Thank you. So coming to the deploy and upgrade, the main thing is the CRDs when we upgrade to a new version. Let's say I have a MySQL operator again, and we have upgraded to version V8 to V9, let's say, and if the operator was not working in V9 as expected, and we want to roll back to V8, the CRD should not break, or if you want to upgrade to V9, but applications are still using V8 CRS, application should not break their functionality. So it should support minimum versions of CRD backward compatibility, right? I'm not saying it should support all the versions that it released so far, but at least it should support N-1 and N-2 of the CRDs that they have deployed, right? So that it has all the applications which are already there using that operator will not have any issues running the operator, right? And second thing is support for upgrade and rollback of operators. So there must be a easy way. So it depends on how you are distributing your operator, like either through OLM or through Helm. You should have a smooth path for upgrading your operator and also rollbacking your operator to a previous version. I've seen there are some operators, I think even the open source operators, where you can upgrade, but you cannot roll back to your previous versions. It will break if you roll back to previous versions, right? So if the operators are, I mean, these are like design way of requirements for the operators. Basically, should support all the upgrade and rollback for maintenance of this operators, right? And I've seen few operators, the open source operators, where they put a node selectors while they're deploying some pods, right? So they should, none of the operators should assume that environment should have these labels or worker names and like different hardware. You should not, none of the operators should not assume. You should, whatever I deploy in my Kubernetes platform should just work if I do on deploying AWS or in different platforms or in different Kubernetes clusters. But if I use the node selectors or no names in the spec, then it's strictly no, and it will not work in all the Kubernetes environment, right? So those are things which I feel it should not be put into the CR logic or in the controller logic there.
So Bharat, so with regard to node selectors, right? We have this NFD or node feature discovery. Would you say that's not something which should be used by operators?
So coming to that, so few network function may have like a dependency on GPU or some specific hardware on the node, right? And there is no way that application will not work without that hardware exist in that node, right? Then it is allowed. But in general, if you want application to be run in any node, then you should have a node selector, right?
Yep.
There is some exception on this, like if it is specifically depends on your hardware, or if you're running an application only on AMD64 but not in the different architecture, then there's no other way, right?
Makes sense.
And it
Thank
should be called out in the operator document that it will only work with nodes, nodes which has the specific hardware, right?
Yep. Makes sense. Thank you.
Yeah, thank you. A couple points I want to raise. One is that actually that is an interesting point in that I think one of the things we're going to find, given the level of complexity of requirements from these network functions, is that we may, I don't know, we may, I probably shouldn't say such a thing, but we may want to consider our own scheduler or something that works. Like, I'm not sure that trying to rely solely on the Kubernetes standard scheduler is gonna meet our needs, but I guess that's a whole totally different topic that I haven't thought through at all. It just popped into my head based on this conversation right now. The main point I wanted to bring up, I wanted to ask a question. You talk about upgrade and rollbacks for operators. So one of the other concerns, and I don't know if this is in Tal's document, but one of the other concerns with using operators is that if an operator is managing, say, 20 instances of an application on the same cluster, and you upgrade that operator, you can no longer you can't manage, or it's up to the operator to implement the how those individual underlying workloads get upgraded. Does it instantly upgrade all of them because you've upgraded the operator? Now it says, oh, I support a newer version of the underlying software, so I'm just going to blast out and upgrade all 20 of these? Or does it provide some mechanisms for doing that in a controlled manner? Maybe the CR itself has to have a tweak or something. So have you seen that issue? Is that another area of concern for you?
Yeah, so these operators, right, it depends totally on the application. If we want to upgrade an operator to upgrade the instance it is managing, then so as you know, when I restart the operator pod, it gets all those events which are like, if my operator is listening on some specific CR, let's say, and if I upgrade the operator, so your pod will restart, or your new pod will be instantiated with the new version, and it receives all those CR events again, which are present in those clusters, right? And it is up to this operator whether it has to read those CR events and see, okay, this is the CR which is from the previous version. I have to upgrade it to a newer version, and what are the steps to follow it. It totally depends on your application whether you want to upgrade your instances also to a new version, or it doesn't matter. It just you're upgrading your bug fixing your operator, right? It depends totally on an application and why you are upgrading your operator.
So you never know when you upgrade an operator unless it's in the documentation what it's going to do.
Exactly. So you're upgrading, and it might have just a bug fix on the operator logic itself. It doesn't have to upgrade the instances. In that case, there is no need of upgrading the instances as such, right?
Yeah. Okay. Thank you.
Right. So the last one is the troubleshooting. So once you have operators installed, everything, RBAC, packaging, everything sorted out, and then at the day end, you have some issue on the operator, and your application which is installed by your operator doesn't work as expected, then how I can troubleshoot those events? I need a first thing first, I need a proper logs from these operator pods. So there should be a format of for all these logs where it should tell this log as I mean, this is a normal software engineering problem, right? All these logs should tell this is a info log, this is a debug log, this is a warn log, but not all operators will use it. So at least this, we have to follow this RFC 5424, I believe, the syslog, at least minimum to start with. All these operators should have proper log format, right? And the second thing is on the monitoring of metrics from the operator itself. So from all this SDKs that we have, the operator SDK or KubeBuilder, now they are providing metrics in build. If I'm not wrong, at least the operator SDK provides metrics support in build. So that you can get alerts if something is going on your operator parts, so that you can bring the right team and then troubleshoot on those operator parts. If there's no metric, there's no way to get the alerts and then proactively fix it, rather than you have to find the issue after the issue clearly arises, and then you have to go and see what is the issue, go debug those issues, right? So if the operator can expose all its custom metrics or what are the metrics it wants to expose, if it is already pre-built in the operator, that would be good good step to have a smoother troubleshooting, right? And the other one is RBAC. So I bring the type 1 operator. Let's say as an application team, I have my own operator. And then because it's deployed in a different namespace, not in my own namespace, I will not have access to the operator pods. I will have access to the CS, but not to the operator pods and logs itself. So I cannot troubleshoot it. Though it is my own operator, I will not have permissions to troubleshoot it because of all these RBAC issues. So the platform admin has to give a special role where he can access the logs and he can do the CRUD operation or operator pods itself. This will not come directly from the operator manifest file. The operator manifest will have just the deployment of the operator or how to deploy it. So only those parts, but the roles and role bindings will not come by default with the operator. So we have to create all those roles and do all the RBAC so that the app team will have access to those operator pods to do all the troubleshooting, check the logs, and then inform the platform admin, say, hey, this is the issue, so can help to fix it, right? So they need a proper logging, monitoring, and RBAC access to troubleshoot all these operators seamlessly. So have a list of operator best practices. I don't say it is exhaustive list, but these are a few things that we have discussed so far. All the operators must certify with the Kubernetes version. It should properly publish what Kubernetes version it supports so far, and what version, like if it supports a Kubernetes 1.23, where the API versions are changed from V1 beta 1 to V1. Does my operator, which is already installed in my cluster, should tell whether it can support Kubernetes 1.23 version or not. It should be able to put all these details. If not, then how to upgrade that to support those. So it should be able to properly define those upgrade paths to support different Kubernetes API versions, right? And the second thing is how the way this guy should be able to configure all the image path or specs, node selectors, affinity rules, deception budgets, all the things should be able to configure and be flexible like that. Third thing, resource quotas and limits. You should be able to receive or take those input from the CS itself, so that all the spots it deploys should take all the resource and limits. And the next one is the taking environment variables. Anything where you put in CS, if you want to take any environment variables, you should be able to flex. Not just resource quotas, environment, it applies for anything which can be configurable, right? And this third, and the next thing is, this is a major issue where some of the CRD names conflict with another operators. So one operator will have same CRD name with another operator. So it would be very difficult. Thing is, so I cannot, if my operator is based on a Golang based operator and everything is compiled, I cannot change my CRD name watch for a different CRD name.
Are you saying from the same vendor or something? Because they should have their own group. They should. I mean, the names might conflict. We can't. We can't necessarily.
It's from the exactly. It's from the same vendor. There
And they're
might be a
different
chances,
versions.
right?
Oh,
Okay.
well, that's just yeah, that's bad.
Yeah.
Because even in the same vendor, they could have their own namespace within the group, right? I mean, it's a DNS name at the end of the day, so they could even say, let's say it's Nokia. I don't know what's Nokia, but they could say group 1, group 2, group 3, and do it that way.
Yes. So those
But
are
okay,
those are the design
No,
level
these are
decisions.
great. These are
Right?
great best practices.
Yeah, it's good. It's very good. But
we're almost out of time, so yeah, go ahead and finish up.
Yeah, so those are the best practices. I mean, those are design level decisions that made before you deploy in the operator, right? So it should be very unique while you are designing your operator itself, so that if you can change the CRD name at runtime, that would be awesome. I don't know if it is possible. At least for Ansible and Python, it can be possible, but I'm not sure if for a Golang based operator, it can be possible to change the CRD as a runtime, right? I don't think so. Yeah. So the other one is this is a normal. I think one of the member has raised this comment. So it should be able to install in a single namespace or multiple. It should be able to flexible. Say, hey, can install. You can watch for the events on a single namespace. I mean, it should be able to work on both namespace code or cluster code. Right? It should be able to. I mean, it is not for all the operators, but some operators need this kind of support, especially on the type 3 operator. It should support both namespace code as well as the cluster code. So the main thing is how as a community we can enforce the best practices. Not all. I'm pretty sure not all of the best practices can be enforced through Nefio. Those some are design level decision, which can be we can propose to the developers who are writing these operators as part of the design. But some other things where we can enforce it. I think I have talked to Tal in one of the Slack DM and also in the last call. I see from Sarah, there's one of the deliverables from Nefio's SDK, right? So we can leverage this Nefio SDK to put all these best practices, whatever we can, as part of the boilerplate code itself, like how operator SDK is doing currently. If we decide on what are the best practices we have to put for the first phase of release, then we can put in that Nefio SDK so that it can generate all those boilerplate code with all these best practices already part of the code itself. So this is one way where we can utilize this Nefio SDK to enforce all the best practices that as a community we agreed on, right?
Yeah, it's awesome.
The other best practices which cannot be enforced through Nefio SDK, we just have to put this in the Nefio wiki. These are the best practices that any developer or any company who wants to consume the Nefio CRDs, they have to. We can just tell them these are the recommendations to use, but there's no way to.
So eventually, we hope to have some sort of compliance or conformance suite that an operator or that a vendor could send their package or operator through, and hopefully we would be able to validate some of these best practices. But you know, it all is how much is how much can we do, you know. But anyway, we're just about out of time. I see Robbie has a hand up. Is that the last slide, or did you have more?
Yeah, this is the last slide. I'm done.
No, this is great. This is super helpful and useful. But Robbie has a hand.
Yeah, thanks, John. So my question is more at a higher level. Like, I mean, from an architectural perspective, I mean, I'm assuming that you have your own service orchestration management system, and then you have this Nefio, right? How do you see your system, actually your service management system, kind of interfacing with Nefio? Because Nefio tries to address a lot of the problems related to, you know, kind of multi-cluster management or deploying network functions across multiple cloud sites and so on. I mean, and 5G being the kind of the main use case here. right? Do you have any ideas on that? Like, I mean, you have not covered. I understand this is a completely different topic that you discussed, but what is your current position on how these systems might interact with each other?
That's totally different area, definitely. So, see, because we have to think from the community point of view, right? So, if we think one orchestration system where not all the telco operators might not use, and the APIs that it interacts. So in orchestration, we'll have different solves to communicate between different components in orchestration itself. But there's no any standard API from the orchestrator to your nephew as such, right? If there is one, then we can make all the orchestrator to comply with those APIs. But as of such, I think we still have to define the scope and what are the deliverables on nephew side, so that we can define properly on what APIs we can standardize, so that all the orchestration can communicate over that API interface to nephew.
Yeah, and I think that's where I think a lot of I would say the community requires inputs on is to come up with a set of requirements so that those open API information models or the CRDs can be kind of aligned with those set of use cases and requirements. So yeah,
and also the sorry to interrupt, Ravi. So also the orchestrator. So some orchestrator will also talk on OpenStack APIs or try to deploy VMs, and Nephew is mostly focused on Kubernetes, right? So we have to consider
anything we can manage with KRM. But I'm sorry, I do have to cut it off. We're already 2 minutes over.
Oh, yeah.
I at least have another meeting. I'm already late too, so I'm sure others do as well. So this was really fantastic. Thank you so much, and definitely this is great input to what we're working on. So really appreciate it.
Thank you.
And like I said, please do share this if you want to make a PDF of it or something and put it on the Google Drive, or send it to me if you don't have access to that, and I can put it on the Google Drive. Reach out via Slack or email would be fine. Or just upload.
Sure, I'll check out how to operate. Yeah.
Okay. All right. Thanks so much.
Thank you.
Thank you
all for all the questions.